So, back our heads together with these. All right.
Video.
So the idea is this. Say you had some function, right?
Mm-hmm.
Just for kick's sake, we'll call it f of x, right?
I've heard that one before.
Okay. And we'll think to ourselves, f of x is y.
Sure. Yeah, that's fine.
Whatever. Okay. So then what I might think is this is the same statement, assuming that f is invertible.
Mm-hmm.
Like if I apply f inverse to both sides, right?
Mm-hmm.
As x is f inverse of y.
Right.
Okay. Now this is a really stupid trick because really I'm thinking about y as depending on x,
Mm-hmm.
right? Really y is just another name for the function f. This is a totally bizarre trick. Doesn't seem like it ought to work at all.
Y is just another name for the function.
Yeah, like I've just named the function f twice. I called it both f and y.
Oh, yeah, okay, yeah.
And then I
Sure.
applied the function f inverse to both sides.
So
really this is just x.
y
right?
undoing y is x.
Yeah, exactly.
Or f undoing f is x.
Yeah.
Cool.
Okay. So then we do this really even dumber thing. I'm just going to slap both sides with a ddx operator.
Sure.
Like whatever the hell that is.
Yeah.
Okay. So that's going to give me ddx of x,
Mhm.
right? And then on this side, I'm going to have ddx applied to f inverse of y.
Okay.
But y depends on x.
Right.
Okay. So basically, I'm just going to say, well, I know ddx of x is 1.
Mm-hmm.
And 1's going to equal, let's see, so here I've got a derivative of a composite function, right?
Mm-hmm.
So I need to apply the chain rule to this thing.
Mm-hmm.
Okay, so I get df inverse dx.
Okay. Y dx. Oh, never mind. Never mind.
I'm just hitting it with
it's
a
fine.
dx operator,
Yeah,
right?
it's fine.
Done to y of x,
Mm-hmm.
right? Times the derivative of the inside,
Right.
right? Which I'm just going to write as dy dx.
Mm-hmm.
And maybe I'll just leave that as doing this thing to y. Right?
Right.
Okay. So this is the object I was interested in, was finding the derivative of the inverse function. And what have I found? Well, if I solve for this by dividing both sides by dy dx, and remember dy dx is a derivative, it's not a fraction, so you can't like flip it and multiply.
Okay.
So what you end up with here is 1 over dy dx is df inverse dx done to y.
Okay. Right. I see it.
Okay, so this gives you a really kind of annoying formula, but it totally works. So you have to remember that this one is being evaluated at x,
Mhm.
and this y was really an f of x, right?
Mm-hmm.
So this gives you a way to evaluate the derivative of an inverse function. Unfortunately, you have to start with, well, we can switch this. So this is at f of x, right, which is my y, and this is supposed to be done to x,
Mm-hmm.
which is really f inverse applied to f of x, right?
Right.
So I can rewrite this in a slightly more usable way, where I do df inverse dx at some y value is 1 over df dx evaluated at f inverse of y. Okay, now this formula doesn't seem particularly useful, and to be honest, it's not. But this idea is super useful because you can get the derivatives for the inverse trig functions out of this. So I'm going to stop this and let you try to get the derivative of inverse sine out of this,
Okay.
and it'll take a minute. But
Sure.